Hello students, in continuation of our previous lecture, this is the derivation for 4-stroke diesel cycle. That is also known as constant pressure cycle. Now we will start again same as the previous derivation with the PV and TS diagram. This is the PV diagram and this one is the TS diagram. Now this is P atmospheric pressure line. Now this is clearance volume, this is swept volume. Now from this point up to point 1, this is suction. When the fresh air comes inside the combustion chamber, 1 to 2 there will be the compression of this air, and at point 2 when the air is compressed and the pressure will be maximum, there will be the supply of fuel, and at point 3 the supply of fuel stops, and this point is also known as cutoff point. This process 2 to 3 is also known as heat supplied process. Now 3 to 4 is the expansion process. At the end of 3, when the fuel supply is stopped, there will be the explosion, and because of that system moves because of the intensity of pressure waves during expansion up to point 4, and that is also known as expansion process, in which system gets the power from the process. Now 4 to 1 is again known as the heat rejection process, because exhaust valve opens and up to from this point up to this point there will be the exhaust. And for 1 to 2 and 3 to 4, the law is PV to power gamma is equals to constant. With respect to this diagram, TS diagram is this. 1 to 2 we are considering that the entropy is constant during the compression process, and again for 3 to 4 expansion process entropy is constant. But that is the theoretical case, that's why we are considering that, but in actual practice it's not possible. Now 2 to 3 is constant pressure process and 4 to 1 is the constant volume process, we can see from PV diagram. Now there are 4 processes. 1 to 2 adiabatic compression process, in which there will be no heat transfer between the system and surroundings. 2 to 3 is the heat addition process. 3 to 4 adiabatic expansion process, and 4 to 1 is the heat rejection process. And as we all know, the efficiency of the cycle is denoted by the eta, and that is a total work done by the heat supplied. That will be the equation number 1. Now we are considering here also few terms, that is compression ratio for the cycle, denoted by the small r, will be the ratio of maximum volume by the minimum volume, maximum volume by the minimum volume, ratio of V1 by V2, compression ratio. Cutoff ratio again denoted by rho, again the ratio of maximum by minimum, V3 by V2. And one more thing here, expansion ratio, the ratio of V4 by V3, V4 by V3. Now as we all know, gamma is the ratio of Cp by Cv. Again the heat supplied equation for this cycle is mCp T3 minus T2. M is the amount of air that we are taking for the process. Cp here is the heat supplied process, is the constant pressure process, so is the specific heat at constant pressure. Okay, and again the difference of T3 minus T2, so this is the heat supplied equation. Now heat rejection equation is mCb T4 minus T1. Why mCb? Because now this is the constant volume process, so here we will take the specific heat at constant volume, so this will be the mCb T4 minus T1. Again when we will put these values in equation number 1 and we will solve, then we will find eta is equals to 1 minus 1 upon gamma T4 minus T1 T3 minus T2. That is equation number R. Now we will solve for equation number 1 to 2, process 1 to 2. We will take PV to power, PV is equals to RT, standard gas equation, where R is the universal gas constant, and P1 V1 to the power gamma is equals to P2 V to the power gamma. With this, when we will solve these steps, we will find ratio of T2 by T1 is equals to R to the power gamma minus 1. I have explained this process in our previous lecture. Okay, so we will not consume the time on that. Again, when we will take the value of T2, we will find T2 is equals to T1 R to the power gamma minus 1. Again for process 2 to 3, 2 to 3 is the constant pressure process. So from PV to power, PV is equals to RT, we will get T3 by T2 is equals to V3 by V2. Again T3 is equals to T2 rho, because V3 by V2 we can see here, V3 by V2 is equals to rho. So we will put the value of T2 here from the above term, so we will get T3 is equals to T1 R to the power gamma minus 1 into rho. Again for process 3 to 4, we will get same as this, T3 by T4 is equals to V4 by V3 to the power gamma minus 1. We will divide this V3 and V4 by V2. So we will get V4 by V2 divided by V3 by V2. We can write this also to the power gamma minus 1. So we can directly replace this here. V4 is equals to V1, because this is constant volume process. So we can replace V4 by V1. So this will be V1 by V2, V3 by V to the power gamma minus 1. When we will solve and will put the value from the above term of T3, we will get T4 is equals to T1 rho to the power gamma. Now, when we will put all the values in equation number R, eta is equals to 1 minus 1 upon gamma, T1 rho to the power gamma minus T1 r to the power gamma minus 1, rho minus T1 r to the power gamma minus 1. We will get after solution the efficiency of the cycle eta is equals to 1 minus 1 upon gamma, rho to the power gamma minus 1, r to the power gamma minus 1, rho minus 1. In some books, we also know that this efficiency is written as 1 minus 1 upon r to the power gamma minus 1, rho to the power gamma minus 1, gamma rho minus 1. So this is the derivation for the efficiency of the cycle for 4-stroke diesel. Thank you.